So I am a nuclear chemist and I do experimental nuclear science, which means that we actually do experiments using the heavy ion beams that are created here at the NSCL. My particular area of interest is in heavy ion reactions. So we take beams of heavy ions that are created and we collide them with a given target and look at the products that are created in the reaction with our detector systems that we have at the NSCL. So in particular, what we're interested in looking at in our research group are neutron-rich nuclei. And this is one of the things that is of particular interest in nuclear science right now, because the majority of the known isotopes are do not have the same number of protons and neutrons in the nucleus. They have more neutrons than protons. So when we look at our heavy ion reactions, we tend to look at neutron-rich nuclei because they can tell us in particular about what properties that are holding the neutrons and protons within the nucleus. About experiments in general, and this applies to the NSCL as well, I think one of the things that people don't realize when they're thinking about nuclear physics experiments and nuclear science experiments is that when you're at a beams facility like the NSCL, the experiments that we run 24 hours a day, 7 days a week. So when you set up an experiment, you are given a number of beam hours that you have to achieve whatever scientific measurement you're trying to make. And that number of beam hours doesn't in any way apply to your normal working hours. Instead, we break the day up into, for example, 8-hour shifts where the students, the grad students, the postdocs, the faculty, everyone takes shifts to help with the experiments and to get the scientific data in. That's really easy. I can do that one.
Right.
Okay, so the NSCL, and this is actually, it's not just advice for students, but it's actually why I came here as well. The NSCL is particularly special because you are at a place where you're at a facility where many people are working towards similar activities, similar objectives. Now, of course, you have to have your own independent research project as a graduate student or as a faculty, but you're in an environment where lots of people are working towards similar issues. And so, in particular about being at the NSCL, the beams that are available here are world unique. We have very good accomplishments in the development of unstable beams. We'll be developing a reaccelerator complex. And what is of key importance, I think, is that the NSCL is a user facility. So not only do we have the people who are here doing work, but we have outsiders coming in who do not have these types of capabilities at their own university. And so you get to have the interaction not only with your colleagues here who are top-notch researchers, but also with everyone who's coming here to do work that is not possible at their home institutions. And as a student, I think that's particularly important because the way we learn and the way we advance this type of science is by the interactions and the hands-on experience that you gain. And if you're at a university or a location that does not have their own facility, you really don't get the interaction and the type of everyday experience that you do here. You choose which field you're interested in based on where you find the most dynamic interaction and response that meets your interests as an undergraduate or as even younger. But in terms of getting into a graduate program on nuclear chemistry and then coming to the NSCL, for me what was particularly important was when I was entering graduate school, choosing your advisor is of utmost importance. You have to have an advisor that you can work with and that you can learn from and who does something that's interesting to you. So for graduate or for prospective graduate students or people who are thinking about going into the research areas, I would encourage them to look at actually the individual interests of the faculty members that they might be working with, because that's at least as important as where you, in particular, what institution you end up at. And one of the things that's really important is finding a place where you will have options as to who you work with. My direction, my path was, largely determined by who I ended up working with and what projects I ended up working on. That sort of defines your direction that you're going in. And you want to make sure that you give yourself every opportunity to find someone that you're going to be successful working with. So if you go to a place, an institution, where you have multiple faculty members who have things that you might be interested in, and then you find a compatibility with studying with one of those faculty members, your career will follow smoothly from there, and you won't have as many glitches, you could say. I guess the one thing that I never expected coming into the field is how much personal connections matter. Um, for example, being a fantastic scientist is of utmost importance for success in nuclear chemistry or nuclear physics. You have to have that basic fundamental. But you also have to be able to communicate your knowledge and to be able to translate that into relationships with collaborators and other scientists, because in this field nobody works alone. The projects are just entirely too big in scope for you to be sort of a lone person out on an island by yourself. So the importance of developing those relationships and those collaborative scientific relationships with other, even graduate students when you're at graduate student level, because they will mature with you as you go through your career, but also with more senior people who will be effective in helping you develop your career. I can't emphasize the importance of that enough, because we like to think that science is pure and it's all based on the scientific concept, but to bring your concepts to fruition, you need to be able to work with other people, and it's not just your scientific knowledge in isolation. That's the most important thing. So that's what I wish someone had told me.